Alright, so today we're doing day 2 in our Unit 1A, Points, Lines, and Planes. So, day 2 is where we're going to start at. Let me move the cursor. Unit 1A, day 2, Algebra Proof Practice. So it's basically going to be like what we did yesterday. We're just going to practice. Okay? We are going to add on one mistake that can be made, and then we're going to add on one more property, maybe 2 more properties that can be done. Okay? So remember yesterday, the following reasons are the justifications most commonly used to prove algebraic solutions. We've got the addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality. Those all happen on one side. Grading yesterday's assignments, a lot of you didn't put the property of equality, that POE. I didn't count it wrong yesterday, but I'm going to start counting it wrong today. Okay, so make sure if it's one of these first 4, for sure, you put that POE. Okay? We have the substitution property of equality. This one, if you don't put the POE, it's okay, because there's not a substitution we do that's not a property of equality, but there is the other 4. We'll talk about in a minute. And then distribution property of equality, you don't have to put the POE on that one. It's just mainly those first 4. Combined like terms happens on one side of the equals, and then given is always what we start with. Okay? So practice problem 1, given that 5x minus 3 equals 52, we're going to try to prove that x equals 11. So the very first thing we need to do is make our table where we're going to have statements. And we're going to have reasons for our 2-column proof. Aptly named because there's 2 columns. Okay? Then you'll always start with your first given statement. Sometimes you have more than one. Right now we only have the one. So 5x minus 3 equals 52. What am I going to put for that reason? Given. Very good. Okay? What should I do as my first step in solving this problem?
Add the 3 to both sides.
Let's add the 3 to both sides. Remember when we're doing that, if you want to show that math, you can, but it's not technically part of the proof. So if I add 3 to both sides, I'm going to do it just in pencil because it's not really part of the proof. Plus 3 plus 3. I know a lot of your teachers in Algebra 1, Algebra 2, algebraic reasoning, whatever we took for algebra, they talk about this canceling out. I don't like to think of it as canceling out. I like to remember that it turns into 0. Negative 3 plus 3 equals 0. Okay, so I like to think, okay, it's really 5x plus 0, which I know is just 5x. Because otherwise we think it just actually disappears and becomes like a black hole. But it's really still there. It's a plus 0. All right, and then on my right-hand side of equals, what am I going to get? It's what?
Addition property of equality.
Oh, no, sorry, I haven't finished my equation. 55. And then it's addition property of equality on the right-hand side of the column. Addition. So a lot of you just wrote that on your assignment last night, and I counted it as correct. But it should be addition POE. I will start counting that wrong on today's assignment. Okay? All right, what am I going to do next? Divide by 5. And so when I divide by 5, again, this isn't part of the actual proof, but some of us like to write it so we can see it. So I did it real light. 5x over 5 is 1x. And then 55 over 5 is 11. And what am I going to put as my reason? Division POE. And then we can see that we have proven x equals 11. We are done. You're done when you've proven what you're trying to prove. Okay? All right. Let's go and look at the next one. Practice problem number 2. So in practice problem number 2, again, I'm going to start off by making my table with statements and reasons columns and then my given. So statements and reasons and then my columns. And I'm going to start with my given, -3 plus x over 3 equals a -13. And that was my given. I'm trying to prove x equals -30. What am I going to do as my first step?
Add 3 to both sides.
Add 3 to both sides. So -3 plus 3 is 0. And 0 plus x over 3 is just x over 3. You said we're going to add it to both sides. So -13 plus 3 is
-10.
-10. And what did I do to get from that first step to the second step?
Addition POE.
Addition, property of equality. Okay? X over 3 equals -10. What am I going to do next?
Multiply 3 to both sides.
Multiply by 3 on both sides. So I'll end up with 3 times x over 3, which is 3 times x over 3. 3x over 3, which is just x. And then -10 times 3, -30. Which if I look up here, that's what I was trying to prove. What do I put as my reason?
Multiplication POE.
Right, we multiplied by 3 on both sides, so multiplication. POE. All right. Let's look at the next page. All right, so practice problem number 3, and I have my reasons up here so I don't forget when you're doing your assessment. You can look at that as well. Okay. Again, I want to start with statements and reasons, my table. So statements and reasons. And I have 2 givens this time. So I'm going to start with 1 and then see what I want to do from there. So I'm going to start with the first one, 4x plus y equals 14x plus 1, and that was one of my given statements. So now I have 2 options. I know I'm trying to prove y equals 21. So I could start solving this for y, or I could put my next given, whichever one we want to do would be okay to do. Anybody have a strong feeling towards one or the other?
Next given.
Next given. Sounds like we're doing that. All right, so my next given is x equals 2. Okay, so now, again, I have 2 things I can do. I can either start solving for y, or I can use that x equals 2 in the first equation.
Substitute.
Okay, let's go ahead and do that then. So you said we're going to substitute, so that means 4. We're going to replace the x with the 2 plus y equals 14. Replace the x with the 2 plus 1. And what am I going to put as my reason?
Substitution.
Substitution. Okay. And if you look in the box, it really is a property of equality, but on this one you don't have to write the property of equality. Okay? What should we do next? Yeah, we want to actually do that multiplication, right? The 4 times 2 and the 14 times 2. So 4 times 2 is 8. And 14 times 2 is 28. And then we haven't really talked about what that is, right? We're multiplying on both sides, but we're not like adding something that we're multiplying on both sides, if that makes sense. So this isn't really the multiplication property of equality because we're not multiplying something new to both sides of the equation. We're multiplying what's already in the equation.
Combine like terms.
Now, so this is not one we've actually talked about yet. You have two options that you can use. You can either call it simplify, or you can call it multiplication just without the POE. Sometimes you'll use divide this way. Not very, well, more so with multiplication than with dividing. Every once in a while you'll get it. Usually it happens after substitution, right? Because you substitute something in and then you need to start simplifying that. So you can either put simplify, or you can put multiplication without the POE. Because the POE implies you're multiplying something new to both sides. This is already part of the equation. Okay? Alright, now what do I want to do? Combine like terms. So I've got 8 plus y. There's no like terms on that side, so it stays 8 plus y. And then my right-hand side, my 28 and my 1 are like terms. That becomes 29. And you said we combined like terms. Okay, now what?
Subtract the 8 from both sides.
Subtract the 8 from both sides. So 8 minus 8 is 0. 0 plus y is y. 29 minus 8 is 21, and that's what I was trying to prove. Y equals 21. So I know I'm done. What do I put as my last reason?
Subtraction POE.
I used subtraction, so subtraction POE. I subtracted 8 on both sides. Okay, questions on practice problem number 3. Okay. All right, practice problem number 4. Again, I'm going to start with my statements. And my reasons. And then make it into a table. And I'm going to start with my givens. My first givens is 4 times x plus y equals 48. That was given. So now I have two options. I can either start getting rid of those parentheses by distributing, or I can put my next given. Either one is correct. What do we want to do? Okay, let's go with the next given. Y equals 6 is given. All right, what do we want to do next? Okay, we'll substitute that y in for 6. So 4 times x plus y, y we know is 6, equals 48. And my reason is substitution. All right, now what do we want to do? Distribute. So if I distribute, 4 times x is 4x, and 4 times 6 is positive 24, equals 48. And that, what's my reason? Distribution, or distributive, or distribute. Could I have used division property of equality there?
Yes.
What would I have divided both sides by? 4. And then I'd have just had x plus 6 equals 48 divided by 4. 12. Okay. All right. So, what's the next thing I want to do? Subtract what? 24 on both sides. So 4x plus 24 minus 24 is just 4x. And 48 minus 24 is 24. Remember, if we had divided by 4, it would have been 12. But we didn't. We distributed. All right, so what's my reason? Subtraction, property of equality. Don't forget the POE or it's wrong. Alright, what am I going to do next?
Divide 4 on both sides.
Divide by 4 on both sides. 4x divided by 4 is 1x. And 24 divided by 4 is 6. And that was the division, property of equality. If I would have used division up here and I end up with x plus 6 equals 12 for this line, then my next one would have been subtract the 6, because right, I'd have just had x plus 6 on this side. Subtract the 6, and when I subtract 6 from 12, I get my 6. X equals 6. It would have been one step shorter, but that's okay. Both ways are correct. Questions on this one? Okay. Let's look at the next page. There's one more property we're going to discuss today, and one more common error that we need to watch out for. So the new property that we're going to talk about is the symmetric property of equality. That says if A equals B, then B equals A. So that you use that when you get stuck with something where you're trying to prove that x equals 5, but you end up with 5 equals x. You use the symmetric property of equality, so symmetric POE, to switch that so that you have the x on the correct side. So if 5 equals x, we can know that x equals 5. It's just moving the different sides of the equal sign. Okay, a common error we see a lot in geometry or in solving algebra problems is when everything cancels out on one side. We need to remember that it doesn't just go into the black hole of the abyss. There's actually a 0 then left on that side of equals. Okay, so we're going to do one more practice problem, and it's going to involve both of these. This common error is going to show up, and we're going to use the symmetric property. Yes?
Could we use that symmetric property like at the beginning of an equation and you write the given and then right after?
You could. Yeah, you could write the given and then immediately switch it around. That would be just fine. Okay? All right. So let's look and see how this works on this practice problem number 5. It says when solving this proof, let's start by moving the 4x away from the left side so we can see how the information above is used. Because I want you to see this common error and I want you to see the symmetric property of equality. Okay? So again, statements. And reasons. I'm going to start, I only have the one given, so we're going to start there, 4x equals 5x plus 32. And that was given to me. So what Attilio was asking is, could we use the symmetric property right now? Because I realized if I move that smaller x over, my x is now going to be on the right-hand side, and I know I eventually want it to be on the left-hand side. Could we use the symmetric property now? Yes, we could. Okay, but because this is asking me to start by moving the 4x, I'm just going to follow those directions for right now. Okay. All right. So it says we're going to start by moving the 4x away from the left side. So how do I do that? What property am I using to move the 4x to the other side? Right. We're going to subtract the 4x on both sides. So what happens, what I see happen a lot of times when people do that, when students do that, is they go, oh, this cancels out, and so I don't have to write it. And so then they just write 5x minus 4x is x plus 32, and they've completely lost their equal sign. And now it's no longer solvable if you don't have an equals. So then they go, oh, well, I guess x just equals 32, because they just magically decide the x goes in between those two things. But it doesn't, okay? 4x minus x is really 0, right? When two things cancel out, they're not really canceling, they're adding up to 0, okay? Or if they're canceling out with division, they're not really going away, they're dividing to 1, okay? So really I have x, I still have an equal sign in the same exact spot, okay? What's my reason for this line?
The subtraction theory.
subtraction POE. Okay? All right, what would I do next on this one? Subtract 32 on both sides. So if I do that, minus 32 minus 32. Again, this doesn't really just eliminate into the abyss. It becomes a 0, right? So on this side, I have 0 minus 32 equals x plus 0, because that becomes a 0. But x plus 0 we know is just x. And what's my reason over here? Yeah, it's okay that we've already used it and we're using it again. It's okay to use the same property more than once. Okay, so we almost proved what we were trying to prove, but not quite. Because I proved that negative 32 equals x, but I want to prove that x equals negative 32. Yes?
Is that where the symmetry comes in?
That's where the symmetry comes in. So to switch the two sides of the equals, x is going to move to the left side, and the left side is going to move to the right side. And that is going to be my symmetric property of equality. Okay? In a proof, every single step has to be written out. So if I ever go, well, you didn't write that step out, you can't just say, well, you know what I meant. Like, I know what I meant, what you meant, because I'm a math major. But we need to make it to where somebody who doesn't understand math at all can follow each and every step. Does that make sense? All right.